There's some gases called greenhouse gases that will absorb infrared radiation and re-emit it and help trap and keep the Earth warm. And so the question is, has the concentration of greenhouse gases been the same over time? Has the climate been the same over the whole Earth's history? So if you go back 4 billion years ago, you'll find that actually the carbon dioxide concentration was 1,000 times greater than it is today. And that is a good thing, because 4 billion years ago the sun was a colder sun, and it produced about 30% less energy. And so if there weren't that greater concentration of carbon dioxide to trap more heat, then the Earth may not have evolved as it has. Now, over time, the carbon dioxide that is in the atmosphere has dissolved in the oceans, and that has served to limit the carbon dioxide, decrease the carbon dioxide concentration in the atmosphere. Now, 3 billion years ago, at the advent of small plants in the oceans that could undergo photosynthesis, that was another way that carbon dioxide was trapped from the atmosphere, and then oxygen was produced. So the atmosphere started changing from an atmosphere with more carbon dioxide and little or no oxygen to an atmosphere containing oxygen. Now, 100 million years ago, dinosaurs did live in a climate that was warmer, because the carbon dioxide concentrations were still higher even 100 million years ago. So over time, the climate has changed. Okay, so how do we know that? There was nobody around back then, obviously, to take data to measure the temperature of the Earth, or the concentration of carbon dioxide in the atmosphere. Well, there are ways that we can predict what the concentration of the carbon dioxide was in the atmosphere and what the temperatures were eons ago. There's two major ways. To get data from millions and millions of years ago, scientists have drilled down into the rock in the bottom of the ocean, and by looking at the change in the types of fossils that tell them, the types of plants that were available, the amount of limestone, calcium carbonate, and whatnot in that rock, they can go back over time and figure out what the concentration of carbon dioxide was and the temperature. More recently, to get data for more recent times, there's this ice core data. And what the scientists do, this is a picture of it, what the scientists do is they have these drills, and they drill down and get ice. And you can see this is the ice drill. You can see the ice coming out here, and they're collecting it. And so they go down to the Antarctic, where there's been ice accumulating for hundreds of thousands of years. And they just drill down and kind of like looking at the rings on a tree. To date a tree, you can see the changes by year in the snowfall, and how cold it is will tell you how much snow there is, and then it's seasonal, the way the ice cores change, and so they can go back in time and look at the data that's trapped in the ice.